How are you, my dear students? I hope everything is okay. Today let's complete our lesson about the atom, where we said before that the atom consists of nucleus, which contain protons and neutrons, where the electrons revolving around it. Of course, each one of you asked himself, how could the scientists know about the atom, electrons, protons, neutrons, although they can't see them with their naked eyes or even by using the advanced microscopes? Today, let's answer together and understand the story of the atom. Let's start in 400 BC, Democritus. Democritus, he was great philosopher, Greek philosopher, where he imagined that if I have a piece of apple or any matter which can divide it into parts, if I have an apple, I can divide it into small parts. Then each part can divide it again into particles, where I can divide this particle again and again until we reach to undividable particle, and he called it the atom. Atom in Greek words, A means no, tom means divide. So the first philosopher who gave the concept of atom was Democritus. But in this time there was another philosopher, and he was more famous than Democritus. He was called Aristotle. Aristotle rejected or refused the idea of the atom, and he said that no, the matter consists of 4 components. What are these components? He said that they are air, water, dust, fire. Okay, Aristotle, have you an evidence for these words? No. Democritus, have you an evidence for your words? No. But because he was more famous than Democritus, the people believed his idea about the matter. Because of Aristotle's idea, which caused a great retard of the development of chemistry for more than 1000 years. Then Dalton, 1803, he refused, of course, or he started to believe in another way with the structure of matter, and by his calculations he said that the matter must be divided into small parts which are called the molecules, and then the molecules divided again into the atom. So Dalton returned back to the concept of atom after about more than 1000 years. Then what about your imagination about the atom? He said that the atom is solid. What's meant by solid? Solid means has no space inside it. Indivisible means it can't be cut again. It has nothing inside it. It's like the sphere. Okay? Then he also said that the atoms can't be broken into smaller pieces. And in any element like oxygen, the atoms are similar. If I have compound like carbon dioxide, so we have 2 or more elements which combine together. So again, the atomic concept of Dalton, number 1, he said that yes, the atom is like a solid sphere. Number 2, he said that the element is or produced from combination of 2 or 1 atoms which are likely similar, which are similar to each other. But what about the compound? The compound made of 2 or more different atoms. Here, like oxygen, O2, it's made of 2 oxygen atoms. They are similar, but here, like H2O, this is compound. Why? Because it is made of 2 different atoms. Then the scientist Thompson. Thompson was a great scientist. He made a lot of experiments. His experiments was called electric discharge through gases. Again, electric discharge through gases. Let's know a simple idea about this experiment. By the way, this is the main idea of the fluorescent lamps. What is happening here? Thompson started to get out a gas, for example, like hydrogen. Then he will get out the gas from here. What's meant by getting out? If I have, for example, 100 milli cubic centimeter or a milli of hydrogen gas, then I will push the gas outside with a vacuum pump. So what is here? Here small amount of gas. Again, here in this tube there is small amount of gas. He found that after decreasing the amount of gas here in this tube, the gas changed to be good conductor of electricity. Then he found that some rays pass from negative to positive. He called these rays cathode rays. What does it mean? He found from his experiments that these cathode rays are the electrons. What is this? So the atom has electrons? Yes. Who discovered the electrons? Thomson. So now, Thompson's atomic model of atom. He said that because the atom must contain electrons which are negative. So what about this one, this sphere? It must be positive to make the atom neutral, as we said before. So again, Thompson's model of atom. He imagined that the atom is sphere, okay, like Dalton and Democritus. But what is new? He said that this sphere is positive charge, where it contains electrons. Why? To make the atom neutral. Again, Thompson's model of atom, he said that the atom like a sphere. What about it? Its charge? This charge is positive, where electrons are embedded. What's meant by embedded? They are found on its surface. So this is the model, or Thompson's model of atom. So the electrons, he said that electrons enter into constituent of all atoms. He said that any matter has atom, and each atom must contain electrons. Where to make the atom neutral, what we said that it is like the solid sphere, which is positive, where the electrons are found on its surface to make the atom neutral. So again, we said that Democritus imagined that the atom is solid. Then Dalton completed his idea. Then Thomson, he was the first scientist by his experiment that proved that the atom has electrons. Then another great scientist, he was called Rutherford. What about Rutherford? Rutherford also did an important experiment. I'm so sorry to get this experiment, but you have to understand. What about this experiment? It is called gold foil. Let's concentrate together. What about gold foil and Rutherford's experiment? Gold foil, the experiment where Rutherford get a very thin piece of gold. He put it here. Then he get a box where inside this box there is alpha particle. What's meant by alpha particle? This is coming from radioactive element. What's meant by radioactive element? Radioactive element like uranium. Of course, you know what is uranium, nuclear reactors and nuclear weapons. This science is coming from the nuclear or coming from the radioactive elements. Elements that emit radiation, like something which is called alpha, beta, gamma. They are sometimes harmful rays and sometimes useful or has no effect on the body. So again, here what's found in this box, there is alpha particle. How can we get alpha particles? From radioactive element, which are used in nuclear reactors. So here, yes, nuclear or radioactive element which get out or emit what? Alpha particles. So here, what is coming from this box? Alpha particles. After hitting this gold foil, what is happening? He found that most of the alpha particles can pass from the gold foil. Can you see? Most of the alpha particles can penetrate the gold foil, where only few amount of these alpha particles can reflect back. So let's understand from this picture again what's happening here. He found that most of alpha particles can pass to the second side, but here he found that only few amount of alpha particles can reflect back. So he started to think, what does it mean? After thinking, he found that, or he decided that there is something here inside or found in the center of the atom. He called it nucleus, and this nucleus must be positive. Why it must be positive? Because alpha particles are positive. So if you can see here positive, they will repel each other, they will move away from each other. Again, what did Rutherford do in his experiment? He said that, or he got box made of by the way, it was made of lead. Then what's found inside this box? Alpha particle, then this very small hole to allow alpha particle to pass where? Yes, excellent, to gold foil. What did he find? He found that there are, or the most percentage of alpha particles can penetrate, where small amount of alpha particles can reflect back. And what does it mean? It means that there is something with high density found inside the atom. Okay, this is number one. What about the charge of this particle? He said that it must be positive. So Rutherford discovered the protons, which are found inside the nucleus, and he said that what makes these particles pass? It means that the atom is not solid, it has empty space. Again, let's describe again the Rutherford's atomic model after his experiment. So he said that the atom is not solid. This is number one. Why? Because the alpha particles can pass to the second side. Then what's found here in the center of the atom? He said that there is dense particle which is called nucleus. This nucleus has positive charge. So he said number one, most of the atom is empty space, not like Dalton's and Thompson's concept about the atom, because he found that most of alpha particles can pass where what is found here, there is here small dense positive charge nucleus. So this is the Rutherfords atomic model. So again we said that Dalton, the atom is excellent, yes, solid sphere. Then Thompson, he discovered the electrons. Number 3, Rutherford, he discovered what? Nucleus and protons. Okay. Then Rutherford's idea failed. Why? What's happening? It is a good idea about the atom, but in this time he didn't explain why do some elements emit or appear as lightning ray, or emit rays like this, or emit light when they are exposed to heat. He didn't explain what is happening for the potassium after heating. It appears in this color, where barium it appeared in this color, where sodium it appears in this color, where calcium it appears in this color, and all of them have different colors. Rutherford can't explain why did each one of them appear with its specific color after heating. So Rutherford's idea failed, but he provides us with very good information about the atom, where the atom is, yes, excellent. Most of the atom is empty space, where the nucleus is found at the center of the atom with positive charge. Okay, let's complete our story. Then another great scientist, Niels Bohr. Niels Bohr, after making a lot of experiments, he explained these colors that appear after heating the elements. After heating barium, it will appear with this color. After heating potassium, it will appear with this color. After heating sodium, it will appear with this color, and so on. What about your explanation, Bohr? He said that after heating, for example, sodium has electrons here in these places. After heating, the electron accept or gain energy. So after gaining energy, it will be excited. What's meant by excited? It will be happy. So it start to move everywhere. So it will move from here to another place, but at once it returns back to its original place. What about the energy it accepted? It will release this energy in the form of this light. Again, for example, if I have hydrogen gas, what about its electron? Its electron is found here in the first place. After heating hydrogen, it will accept energy from where? From the fire. Then what is happening? Again, it will be happy. So it will move from this place to another place. Then at once it returns back to the original one. What about the energy which is accepted? It will emitted in the form of the color which is appeared. So from this explanation, he found that the energy levels. What are energy levels? Like the planets. The planets revolve around the sun in imaginary places called orbits. The same here like the atom. He said that the electrons are revolving around the nucleus in specific places, in a definite places. He called them energy levels. Bohr, how many energy levels? He said they are 7. What about their names? He called them K, L, M, N, O, P, Q. So, what is new about Bohr? Bohr explained what is happening for the element after heating. Each element produces new color or specific color. How could he explain these colors? He said that when the electron absorb energy after heating, yes, we said it will be happy, then it will transfer into higher energy level, but at once it returns back. What about this absorbed energy? It will emit in the form of light. Then he explained that each electron is found in a definite allowed energy levels. How many energy levels? There are 7. What about their names? K, L, M, N, O, P, Q. So, excellent Bohr. But nowadays, a lot of scientists collect together and modified Bohr's idea about the atom. These scientists were Einstein, Schrödinger, Heisenberg, and a lot of scientists. What did they say? They said that instead of the presence of electrons in energy levels, he changed the concept of energy levels into electron cloud. What is meant by electron cloud? They said that the electron may be found everywhere around the atom except the nucleus. So this is today's atom. What about neutrons? In 1932, Chadwick said that there are neutrons inside the atom or inside the nucleus, and in 1932 he provided the evidence about his idea with the experiments. I know that it is difficult for you. You have to hear this lesson a lot and a lot. You have to ask me if there's something you can't understand. I'm ready for your questions. Okay, now let's see this video to try to understand.
What do an ancient Greek philosopher and a 19th century Quaker have in common with Nobel Prize-winning scientists? Although they are separated over 2,400 years of history, each of them contributed to answering the eternal question, what is stuff made of? It was around 440 BCE that Democritus first proposed that everything in the world was made up of tiny particles surrounded by empty space. And he even speculated that they vary in size and shape, depending on the substance they compose. He called these particles atomos, Greek for indivisible. His ideas were opposed by the more popular philosophers of his day. Aristotle, for instance, disagreed completely, stating instead that matter was made of 4 elements: earth, wind, water, and fire. And most later scientists followed suit. Atoms would remain all but forgotten until 1808, when a Quaker teacher named John Dalton sought to challenge Aristotelian theory. Whereas Democritus's atomism had been purely theoretical, Dalton showed that common substances always broke down into the same elements in the same proportions. He concluded that the various compounds were combinations of atoms of different elements, each of a particular size and mass, that could neither be created nor destroyed. Though he received many honors for his work, as a Quaker, Dalton lived modestly until the end of his days. Atomic theory was now accepted by the scientific community, but the next major advancement would not come until nearly a century later, with the physicist J.J. Thompson's 1897 discovery of the electron. In what we might call the chocolate chip cookie model of the atom, he showed atoms as uniformly packed spheres of positive matter, filled with negatively charged electrons. Thompson won a Nobel Prize in 1906 for his electron discovery, but his model of the atom didn't stick around long. This was because he happened to have some pretty smart students, including a certain Ernest Rutherford, who would become known as the father of the nuclear age. While studying the effects of X-rays on gases, Rutherford decided to investigate atoms more closely by shooting small, positively charged alpha particles at a sheet of gold foil. Under Thomson's model, the atom's thinly dispersed positive charge would not be enough to deflect the particles in any one place. The effect would have been like a bunch of tennis balls punching through a thin paper screen. But while most of the particles did pass through, some bounced right back, suggesting that the foil was more like a thick net with a very large mesh. Rutherford concluded that atoms consisted largely of empty space, with just a few electrons, while most of the mass was concentrated in the center, which he termed the nucleus. The alpha particles passed through the gaps, but bounced back from the dense, positively charged nucleus. But the atomic theory wasn't complete just yet. In 1913, another of Thompson's students by the name of Niels Bohr expanded on Rutherford's nuclear model. Drawing on earlier work by Max Planck and Albert Einstein, he stipulated that electrons orbit the nucleus at fixed energies and distances, able to jump from one level to another, but not to exist in the space between. Bohr's planetary model took center stage, but soon it too encountered some complications. Experiments had shown that rather than simply being discrete particles, electrons simultaneously behaved like waves, not being confined to a particular point in space. And in formulating his famous uncertainty principle, Werner Heisenberg showed it was impossible to determine both the exact position and speed of electrons as they moved around an atom. The idea that electrons cannot be pinpointed but exist within a range of possible locations gave rise to the current quantum model of the atom, a fascinating theory with a whole new set of complexities whose implications have yet to be fully grasped. Even though our understanding of atoms keeps changing, the basic fact of atoms remains. So let's celebrate the triumph of atomic theory with some fireworks. As electrons circling an atom shift between energy levels, they absorb or release energy in the form of specific wavelengths of light, resulting in all the marvelous colors we see. And we can imagine Democritus watching from somewhere, satisfied that over 2 millennia later, he turned out to have been right all along.
Thanks guys. Try to study, waiting for your questions. Goodbye.